I'm Steve Proctor. We'll be spending just a few moments talking about dial indicators, or indicators in general. There are several different types of indicators you can work with. The two most common are travel indicators, which will simply tell you how far something has moved or what the displacement of a feature is, versus something with a test indicator, which is more commonly used to double check for zero and run out on parts as they're spinning perhaps slowly in a lathe or on a zero center. Again, we have several different types. We have a dial indicator, which is usually going to include a major dial and a minor dial. The minor dial is going to tell you a little more about where you are in the full travel of the indicator, while the major dial is going to look at the particular micro measurement you're making. This indicator here is resolved at 1/1000 of an inch and simply just up and down, usually returns. It's going to be important to make sure as you use these that your contact points are always screwed in nice and tight. If they're loose, they're going to affect the measurement and it'll be nice and unrepeatable. These are going to come in several sizes, all the way down from very short travels to 2-inch travels, even some experience with some that get up to 4-inch of travel. The specification on these is going to vary as far as how accurate they're supposed to be between the manufacturer's specifications, what they made them to be, and the national spec. The national spec is going to change. The farther up I go in the range of this indicator, the larger the tolerance is going to get. So you want to make sure as you're using it, you're picking the correct indicator for the dimension you're trying to measure and the specifications you're trying to meet. Digital indicators work on the very same principle, that we're just looking to make a travel indication. These are going to be anywhere from 1/1000 to 1/10 to 50 millionths, and some indicators will even claim 10 millionths resolution, just depending on what you need. They are going to be specified for their tolerances just a little bit differently, depending again on the manufacturer and how it is set up in the particular standard you're measuring to. Usually with these, you can set the datum anywhere you need to just by setting the 0 button. You can always preset if you're dealing with a very large part, and you can always set tolerances on most of these. Most of these are going to have a setup where a user can simply put a part under and it will tell them you're in or you're out, depending on what's needed. This is usually going to be set up according to the specification. The great thing about digitals is you can usually go back and forth between English and metric measurements without any converting. As you'll know here on a dial indicator, it's one or the other. On a digital, you can choose which way you're looking at. On the test indicators, usually you're going to have a greater resolution and a greater accuracy because they don't travel as much. The measurement here is taken simply by this lever tip. The lever tip moves, a series of gears and clockworks inside of here works out to turn our dial. We're going to get these in several resolutions. Most common for on-site work with most shop floors is going to be about 5/10 to 1/10. Most laboratories are going to be working within 50 millionths here and there, depending on what tolerances they're needed. An important thing to remember about the test indicators here is that the length and the ball size on the end of this probe tip are actually very important to the measurement. Switching that out is going to change the relationship of the measurement to the gearing to the dial. And so you'll end up with bad measurements if you swap contact points between different devices that aren't meant to be swapped. Sure, the threads will fit, but it's not going to give you a good measurement. Handling, cleaning, and storage. You do want to make sure you protect these. They are basically clockwork devices on the inside, and most of these are dealing with glass scales on the inside. Dropping them is going to be very detrimental to their function, so they're not going to function properly. Just a simple bend here, or a bend here, or even a bend here, or just a broken ball in here is going to severely damage the gauge. What you're going to do is make sure that you're handling them gently. You're going to mount them gently. You'll set them in their cases or their storage places gently and make sure they're protected at all times. Cleaning them, again, just a mild cleaner. Usually you can get away with just toweling them off with a lint-free towel, making sure everything is wiped off and clean, making sure that no debris gets up inside of the travel of the stem. The same with all the indicators. Just keeping them clean is incredibly important. The biggest measurement errors that we find on indicators are usually cosine and trigonometric errors because they're not mounted properly. Where we have this indicator traveling vertically, if it were skewed to the side a little bit, that same amount of travel, it was going to register differently on the device face. So we want to make sure that we're mounted vertically, or at least perpendicular to the surface that we're measuring if we're measuring something off to the side. We're going to want the same kind of setup with watching out for errors on the dial test indicators, because the angle of the probe tip to the surface is actually really important. The same type of error that we see in standard indicators we'll see in these. What we want to do is make sure that our angle is not too great. Otherwise, any upward travel doesn't translate to linear travel properly. So as much as you can, keep it as level to it as possible. This is going to be really easy with these because most of them are easily adjusted for whatever viewing angle you need versus the measurement angle you need.